Welcome to While We Were Distracted, the podcast where we explore topics that often get overshadowed in the rush of daily life.
Imagine a bank, right? Like a bank that prides itself on being the absolute most secure, impenetrable fortress in the world.
Right, like the gold standard of safety.
Exactly. And then they accidentally publish the exact blueprints to their vault and the patrol routes of all their guards in like a public newsletter.
Just mailed out to everyone.
Yeah, mailed out to everyone. And on March 31st, 2026, the AI development world basically saw exactly that happen.
It's still kind of hard to believe.
It is wild because Anthropic, a lab that is fundamentally built on this safety-first brand, they accidentally exposed over 500,000 lines of their Claude Code source material.
Yep, 500,000 lines.
So today we are doing a deep dive into two really critical sources on this event. We've got a high-level news report from Axios looking at the business fallout, and then a deeply, deeply technical threat analysis from the AI security firm Straker.
And that second one is where things get really interesting.
Right. Because the mission for this deep dive is to look way past the immediate business embarrassment, you know? We want to understand for you, the listener, why this specific leak fundamentally shifts the entire threat landscape for AI coding agents.
Yeah, I mean, the headlines are completely fixated on the competitive angle.
Unreleased feature flags, internal data.
Exactly, the free engineering education handed to rivals. But security researchers are looking at this in a completely different way.
Oh, so?
Well, having the unobfuscated blueprints to an AI agent doesn't just reveal trade secrets. It literally allows attackers to map the agent's internal logic and then weaponize the system's own memory against it.
Wow. Okay, so let's trace how those blueprints actually got out in the first place. Because this wasn't some sophisticated zero-day cyber heist by a nation state, right?
No, not at all.
Axios points out it was basically a simple human error. There was this 59.8 megabyte JavaScript source map file that was just accidentally included in version 2.1.88 of the Anthropic AI Claude Code NPM package.
Right, the add Anthropic A Claude Code package.
Yeah. So for the listeners who might not be in the weeds on deployment, what exactly is a source map file?
So for developer shipping software, a source map is basically a standard translation file.
Right.
You write your application in TypeScript, right?
Right, which is like highly structured and easy for humans to read.
Exactly. But you don't ship that. You compile it down to minified JavaScript for actual production. It's smaller, it runs faster, but it's basically unreadable.
Just a wall of text.
Yeah. So the source map lets you reverse that process. It's there if you need to debug something in production. You can map the minified code back to your nice readable TypeScript.
Gotcha. So by leaving that source map in the public registry,
Anthropic inadvertently handed over roughly 512,000 lines of their original TypeScript source code.
wow.
And, within hours, it was mirrored all across GitHub.
So Axios notes that Anthropic confirmed it was just a release packaging issue. No customer data was exposed, which is good, but, and this is a big but, it's their second leak of this nature in just over a year.
Yeah, that's a tough track record.
Handing competitors your unreleased roadmap is obviously a bad day at the office. But I have a question about the software itself. The AI hasn't actually changed, right?
That's correct.
It's the exact same Claude code running today as it was the day before the leak. So why does simply reading the code suddenly make the tool more dangerous?
That's the million-dollar question. To understand that, we have to look at how exploit research actually works. Specifically, this concept of cost.
Cost in terms of time and money.
Both. Before this leak, the internal logic of Claude code, like what an agent is allowed to read, how it parses commands, what triggers a human approval prompt, all of that was a black box.
Right, you couldn't see inside.
Exactly. So if an attacker wanted to exploit Claude code, they were basically blindly brute forcing prompt injections. They were spending massive amounts of time and compute just, guessing in the dark.
They were throwing payloads at the wall and just hoping one of them didn't trigger an error message.
Precisely. But the Straker analysis emphasizes that while a dedicated attacker could have, maybe, eventually, reverse-engineered parts of the minified production code.
Which would take forever.
Right. Having the fully readable TypeScript collapses that research timeline entirely. The time and cost barrier to finding a vulnerability literally drops to near zero.
Yeah, because they have the map.
They don't have to guess how the black box works anymore. They have the source code explicitly detailing the exact boundaries of every security filter.
Okay, so the cost of finding the exploit drops to zero because the logic is totally visible. And when Straker actually read that logic, the first major vulnerability they found was in how Claude code manages its own memory, right?
Yes. specifically something they call context poisoning via the compaction pipeline.
Context poisoning. Okay, so we know AI agents have context windows. Like, they can't remember an infinite amount of text.
Right, they have a token limit.
So they have to compress old information to make room for new information. It's like packing a suitcase, right? You have to throw out old clothes to fit new ones. But some items, like your passport, are marked never throw away.
That is a perfect analogy.
So what does the leak actually reveal about how Claude handles that compression?
Well, the leaked source code, specifically in a file called query.ts, reveals a highly specific 4-stage context management cascade.
4 stages. Oh,
Right. The stages are tool result budgeting, micro-compact, context collapse, and finally auto-compact. And each stage executes very specific rules about what data gets discarded and what data is preserved.
so it's filtering as it goes down.
Exactly. And what makes this a massive vulnerability is that the readable source reveals exactly which types of data are immune to compression.
Oh, I see. So certain data gets like a VIP pass to skip the line?
Basically, yes.
So if I'm an attacker, I just need to figure out which data types get that VIP pass, and I can just park my malicious instructions right there.
You've nailed it. And the code shows that during the first stage tool result budgeting, any tool with a parameter set to max result size chars, Infinity completely bypasses that budgeting stage.
Wait, Infinity? What kind of tool gets an infinite size limit?
That parameter is typically used for tools that read local files,
Oh, of course.
because you don't want the agent reading a file and just cutting it off halfway through.
Yeah.
So once a model reads a file, its contents are essentially frozen in the context.
Okay, so that's stage 1. What about the next stage?
In the micro-compact stage, the code lists a specific set of what they call compactable tools. But model context protocol tools, or MCP tools, are conspicuously missing from that list.
Let's pause on MCP tools for a second, because that's crucial for anyone using these agents in an enterprise. Model context protocol tools are basically the bridges that allow an AI agent to connect to external data sources, right?
Yeah, exactly.
Like, they let the agent pull data from a company's internal Slack or a GitHub repository.
They are the standardized interface for agents to interact with the outside world. And the leaked blueprints show that data pulled in through these MCP tools is never microcompacted.
Never.
Never. So an attacker knows that if they can get their payload into a file read by the agent or injected via an MCP tool, it survives those early compression stages completely intact.
It just stays in the model's active memory.
Yep.
But staying in memory is one thing. Straker points out that the final stage of the pipeline auto-compact actually launders the malicious content.
This is the craziest part.
How does the system end up laundering its own memory?
So during auto-compact, the system triggers a prompt that instructs the model to summarize the conversation so far, right, to free up maximum space.
Right.
Well, the leak prompt tells the model to preserve all user messages that are not tool results, and it explicitly directs the model to pay special attention to specific user feedback.
Oh, no.
And then it tells the model to continue without asking the user any further questions.
Wow. Okay, so let me play this out. If I'm a developer using Claude Code, and I clone some random repository off GitHub that happens to have a standard Claude de.md text file in it, the agent reads that file.
Right, using the file reading tool.
And if an attacker hit a command in that text file saying, I don't know, dangerously disable sandbox, true, the agent's file reading tool gives that text VIP status. It survives until the auto-compact triggers.
Exactly.
Then, because the system tells the AI to prioritize user feedback, the AI looks at that hidden command, assumes that I, the trusted developer, wrote it, and permanently bakes it into its core memory summary.
The context is officially poisoned.
But wait, isn't the AI trained to ignore malicious commands? Like, why doesn't the safety training kick in and say, hey, disabling the sandbox is bad?
That is the most fascinating insight from the Straker source.
Yeah.
The model is not jailbroken in the traditional sense.
It's not.
No, it hasn't had its safety guardrails forcibly bypassed. It is acting entirely cooperatively.
Oh, I see, because it thinks the instruction is from the user.
Exactly. By surviving the compaction pipeline and being labeled internally as user feedback, the poisoned instruction circumvents the safety training entirely. The AI genuinely believes it is following a direct, legitimate order from its user.
That completely flips the script on how these agents are compromised. The agent isn't rebelling, it's just being aggressively helpful to a malicious text file.
Yes, it's terrifyingly compliant.
But wanting to disable the sandbox and actually executing a bash command on my machine are two very different things. I mean, Claude Code doesn't just have free reign over the terminal, does it? There are physical permission systems in place.
There are, and they are actually very extensive.
Okay, good.
The leaked code in toolbashsecurity.ts outlines over 25 different validators that a shell command has to pass through before it executes.
25 bouncers at the door.
Right. And these validators use regex matching, shell quote parsing, and something called tree sitter abstract syntax tree analysis, often referred to as AST.
AST. So instead of just reading a command as a dumb string of text, AST analysis breaks the command down into a grammatical tree.
Right. Yes.
It maps out the verbs, the nouns, the actual structure of the command to understand the intent behind it, which makes it much harder to fool with simple obfuscation.
It's a very robust way to analyze code. The 25 validators check for dangerous flags, malicious redirects, unauthorized file access, all of it.
So if I have a nightclub with 25 highly trained bouncers checking IDs, how is someone still getting in?
Well, again, because the blueprints are public now, attackers don't need to guess what those bouncers are looking for. They just read the source code to find the blind spots. And Straker highlights 3 specific gaps in this armor.
Let's go through them. What's the first one?
They call it early allow short circuits.
Early allow short circuits. Okay, so if there are 25 validators, they must process the command in a sequence, right?
Right.
Does an early allow short circuit mean if validator number 1 gives the green light, the other 24 just pack up and go home?
That is exactly how it functions.
You've got to be kidding me.
I'm not. The code reveals that certain validators, such as validate JIT commit, can return an explicit allow signal. And when that happens, the system bypasses all subsequent checks.
Wow.
And it gets worse. The leaked source code actually includes Anthropic's own internal developer comments mapping out a previous exploit based on this exact flaw.
Oh man, leaving the comments in is brutal.
A comment explicitly notes that if validate JIT commit returns allow, the validate redirections check never runs.
Okay, so this means an attacker can structure a command that looks like a harmless git commit to the first validator, but actually includes a redirect to overwrite a sensitive file, like the user's bash share tree configuration file.
Precisely. They basically handed over a map with a giant red X on the structural weaknesses.
That is wild. Okay, so what's the second gap Straker found?
The second gap involves parser differentials.
Parser differentials.
Yeah. Within the Claude Code architecture, commands are evaluated by 3 different internal parsers before they even reach the actual terminal. The vulnerability lies in the fact that these parsers handle edge cases differently.
It's like having 2 different translators trying to interpret a highly specific dialect, right? Like the JavaScript parser might read a carriage return as a period, ending the sentence.
Right.
But the actual bash terminal might read that same carriage return as a space, keeping the sentence going.
That dialect analogy perfectly captures the mechanism. The leak explicitly documents that the internal JavaScript parser and the actual bash system treat carriage returns differently.
So if you know exactly how the 2 translators differ,
Attackers exploit those differentials systematically. They craft a payload that the security parser fundamentally misinterprets as safe, knowing that the underlying terminal will actually execute the malicious intent.
it sneaks right past. Okay, and the third gap.
The third gap centers on discardable warnings and incomplete parsing capabilities.
Discardable warnings, meaning the system flags it but then ignores its own flag.
Essentially, yes. The system has rules where if a validator flags a dangerous character, like the greater than symbol used for file redirection, but it doesn't trigger a hard misparsing error, the system will discard the warning entirely if the user has configured broad allow rules.
Ah. So if a developer has a rule that automatically allows any echo command without prompting them,
Then a malicious payload like echo payload batchit can breeze through the entire 25 validator chain.
just because the user said echo is fine.
Exactly. Additionally, the analysis found that the internal extract quoted content function completely fails to parse NSIC quoting syntax.
Wait, what does that mean? ANSIC quoting.
It looks like a $ followed by single quotes. Basically, if you wrap your payload in that syntax, the validators literally can't read it.
They are blind to the payload.
Yep, so they just let it through.
Oh my gosh. Okay, when we step back and look at these 2 massive vulnerabilities together, it's pretty staggering. First, you have context poisoning, where the attacker uses the agent's own memory compression to convince the AI to run a malicious command. And then you had the sandbox bypass, where the attacker uses the exact layout of the 25 validators to format that command so it slips right past the terminal defenses.
And the combination of those two exploits illustrates a profound paradigm shift in AI security. The Straker analysis refers to this as the inverted threat model.
Inverted threat model. Tell me more about that.
Well, historically, enterprise security has approached AI agents with the assumption that the model itself might go rogue. The defensive mindset is totally oriented around protecting a cooperative human user from an adversarial AI.
So we've been putting all our alarms and laser grids on the front door to keep the burglar out.
Right.
But the burglar just mailed themselves in a cardboard box, and our own trusted butler carried the box right past the lasers into the living room.
Exactly. The AI is the butler. The AI is inherently cooperative. The true threat is the context.
The text files it's reading.
The files, the memory, the working environment. The context itself is weaponized to poison the cooperative model, turning it into an unwitting proxy.
So it generates commands that look entirely plausible to the human developer. So the developer just hits approve.
Yes, the standard guardrails fail completely because they are busy inspecting the AI's final output, completely missing that the AI's internal reasoning was corrupted by its own memory pipeline.
And this inverted threat model isn't just an Anthropic problem, is it? Because if the context is the weapon, then the entire supply chain of how these agents get their context is vulnerable.
Broadly across the enterprise landscape, you see the exact same compaction pipelines and the exact same model context protocol interfaces being deployed.
Everywhere.
Everywhere. And because the exact interface contract for Claude Code is now public, crafting a convincing, malicious MCP server is trivial.
Anyone can do it.
An attacker can publish an MCP server on the NPM registry that looks incredibly useful, but quietly exfiltrates data using the exact same privileges as the agent's built-in tools.
Which brings us to the most chilling detail in the Axios report. Because this isn't just theoretical. The very same day Anthropic accidentally leaked their code March 31st, between 0.21 and 03.29 UTC, there was a massive concurrent supply chain attack on the wildly popular Axios NPM package.
The timing is incredible.
Yeah.
And it really highlights the reality of the threat landscape. Developers who happened to install or update Claude Code during that specific window might have pulled down malicious versions of dependencies.
Right at the exact moment the blueprints were leaked.
Right. The infrastructure to execute supply chain attacks is already highly active. Now, the blueprints to bypass the internal security of the agents operating within that supply chain are public knowledge.
Okay, so if you are listening to this right now and you actively use Claude Code or similar agentic tools in your development workflow, your immediate question is likely, what do I do? How do I protect my repositories right now? Let's run through the specific hygiene steps recommended by the threat analysts.
Let's do it.
First, you need to audit any claudi.md files in repositories you clone, especially if they come from pull requests or forks.
Yes, because those files are the primary vector for context poisoning. You also need to treat MCP servers with the exact same extreme caution you apply to third-party NPM dependencies.
So vet them thoroughly.
Vet them thoroughly, pin their versions, and monitor them for any unexpected updates.
And on the terminal side, avoid broad bash permission rules. Stop using rules like bashgit because, as we saw with the discardable warnings, broad rules give malicious payloads the exact camouflage they need to slip past the validators.
Absolutely. You should also monitor your Claude directory for configuration changes. And whenever possible, pin your Claude Code version and verify the binary hashes rather than just relying on standard NPM updates.
Okay, and what about the memory compaction vulnerabilities? How do we defend against that?
You need to actively limit your session length for sensitive work.
Because of the compression.
Right. The longer a session runs, the higher the context pressure builds, and the more likely the auto-compact feature will trigger.
And that compaction window is exactly when the context laundering attack occurs.
Exactly. Keeping sessions short prevents the system's memory from compressing in the first place.
Oh.
And it should go without saying. But never use the dangerously disable sandbox command in shared or production environments.
Never ever. The Straker analysis also highlights that enterprise tooling is adapting to this inverted threat model. Solutions like Discover AI can map out every agent and MCP server running in your environment.
Which is critical for visibility.
Right. And Ascend AI allows teams to proactively red team and probe these exact parser differentials and failure paths we talked about, while Defend AI focuses on runtime security to detect prompt injections as they actually occur.
The tools are out there to map your attack surface before someone else does it for you.
So as we wrap up this deep dive, this entire event really raises a fundamental question about the future of autonomous systems.
It really does. We've spent this time dissecting how the greatest threat to an AI agent isn't a human hacker actively breaking the system.
No, it's the passive text files.
Right. The passive text files and context the agent is required to read just to do its job.
Which is terrifying.
It is. If an agent's logic and memory can be so seamlessly corrupted just by parsing a poison file, how can we ever fully trust a truly autonomous agent to browse the open, unfiltered internet?
Will the next evolution of AI require a separate class of, guardian agents whose only purpose is to constantly fact-check, isolate, and scrub the memory of the working agents?
It's highly possible. It completely reframes how we think about trust in software. The AI isn't the threat. Everything the AI reads is the threat.
Wow. Anthropic may have just accidentally mailed out the blueprints to the vault, but in doing so, they showed the world that the foundation of the vault was built on sand. Thank you for joining us on this deep dive. Check your repositories, keep questioning the tools you trust, and we'll catch you next time.
Don't forget to like and subscribe for the next episode on While We Were Distracted.